Alright, this video is on compounds, specifically ionic compounds. But before we get too far into ionic compounds, let's first describe what a compound is. Okay, now a compound is any substance that is composed of atoms made from atoms of more than one element. So for example, if I was to take three examples, sodium chloride, um, ammonia, and nitrogen gas. Okay? So looking at these three right here, if I'm trying to identify it as a compound or not, I really need to see if there is more than one element represented. So here, an easy way to do this, the easiest way, is count the number of capital letters. If there's more than one, it's a compound. So here's sodium, here's chlorine, right? I have two different atoms, or two different elements there, therefore this is a compound, right? Nitrogen and hydrogen. I have two different elements there, compound, right? Um, Nitrogen, for nitrogen gas, which composes our majority of our atmosphere, is just N2. I only have one element there. That is not a compound, okay? So the specific types of compounds we're going to be learning in this video are ionic compounds, meaning that these are compounds that are composed of ionic bonds, okay? So looking at that, so an ionic compound is a compound, meaning a substance made of more than one element, a compound that is brought together by ionic bonds. Now you're thinking, well, an ionic bond, we did the reading on it, we did the coloring plate on it. An ionic bond is the transfer of an electron, specifically the valence electron. Okay, transfer meaning you are either gaining, right? You either gained it or you lost it. And I'll go ahead and show you what I mean by gaining or losing and this transfer of an electron, and that this ionic bond that forms really isn't a quintessential bond like we normally think of. It's just an attraction between two ions. Okay, so let's look at sodium. Right, sodium's Lewis dot structure is right here. Okay, and then we have chlorine's Lewis structure, which is there. Okay, so here I have my two atoms of these two elements, and obviously they're not happy, right? Sodium has that one valence electron that's trying to get rid of it. Chlorine has this 7 valence electrons. It wants to have 8, so in order to get its outer shell filled. So as it turns out, match made in heaven, right? This sodium electron ends up coming over to chlorine, right? That forms two different ions here. It's going to form a chloride ion, right? And the reason why I have that negative charge is because now that I've gained that electron, I have more electrons, more negative charges, than I have protons, positive charges, right? So at the beginning, chlorine, right now, with this extra electron, chlorine has 17 protons, but now it has 18 electrons, right? Because this electron right there is now the 18th electron. Since there's now more negatives than positives, my overall charge is negative. Sodium lost its electrons, so it had 11 protons, and it had 11, it still does have 11 protons, but it had 11 electrons, but it lost one. So now it has 10 electrons, and that is going to result in a sodium plus, because now I have more protons than electrons, right? Now, the attraction between this positive charge and that negative charge is known as an ionic bond, right? They don't really ever come in contact with each other. They're not like smooshed together, or they're not in a covalent compound or a covalent molecule where they're sharing electrons that we'll learn about later. But they're just, there's two ions, they're oppositely charged, they're attracted to each other. That attraction is the ionic bond. Now, what we're going to do in this video, in addition to just showing you how this bond forms, is how to predict what these compounds are based on the ions that I've given you. Okay, so for example, let's pick two elements from the periodic table. I'm going to go ahead and pick magnesium, and I'm going to pick fluorine. Okay, so hopefully we can look at the periodic table, right? And you see that magnesium has two valence electrons, right? And I'm going to go ahead and change fluorine's color here, right? And magnesium has two valence electrons, fluorine has 7. It wants to have 8. Magnesium wants to get rid of its 2. Well, this electron right here will come over here and it will make fluorine happy. It'll turn fluorine into fluoride, which is awesome for fluorine anyways. Magnesium is still in the same boat. It only has one extra electron now, so it's really, really, really wanting to get rid of this other electron so it can have its outer shell filled. Well, as it turns out, that means if fluorine's already happy, it needs another fluorine or some other element or some other atom in order to give up its electron, right? So now if I get rid of those 2 electrons, okay, so the electrons are gone now, that means magnesium is a 2+ ion, as we should know from the periodic table, right? And then now I have 2 fluorine ions, both with -1, because they each gain an electron. So big moment here is, how do I write the formula for magnesium fluoride, or the ionic compound composed of magnesium and fluorine? Okay, so if I look, I'm going to go magnesium. Okay, I only have 1, so I'm going to just write out magnesium. If I had more than 1, then I would have to include a little number right here known as a subscript. Okay, we've all seen it, right? You've seen it right here, right? Water, 2 hydrogens, 1 oxygen. This right here is known as a subscript. Okay? Well, here, because I have only 1 magnesium, I don't have a subscript because you never see a subscript of 1. Now, with the fluorine, okay, I have 2 fluorines here. So I'm going to have a fluorine, but because I have more than 1 now, I'm going to include that subscript. Okay? So this would be the formula for magnesium fluoride. Okay? So if I was to, another way to do this, and I'm going to go ahead and bring this here. So that was the broken down way to do that. And there is a kind of a shortcut way to do it. Okay, and I'm going to show you that right now too. Okay, I'm going to leave the final answer up. Right? It's, if I have magnesium, which I know is going to form a 2+ charge, and I have fluorine, which I know is going to form a -1 charge, how can I combine those 2 ions into a formula like this down here, right? And all I need to really do is make the charge number the subscript and switch them, okay? Or flip the, pretty much flip the switch, how I used to say it, okay? And to show that, I'm going to take magnesium. I'm always going to write the metal first. Metals, okay, or the cation is always first. Always, right? So the metal has to be listed first. You cannot write this. That doesn't work. It's always metal first, right? Magnesium. Now, if I want to know what subscript I'm going to use for magnesium, I want to look at the number charge of the other ion, in this case 1, so I have 1 magnesium. Fluorine, I want to know how many fluorines I need. I need to look at the number of charge on the other, of the cation in this case, and it's a 2, so I'll put a 2. Okay, so we'll do a couple more examples, and then that'll be it. All right. Okay, so I have potassium and I have sulfur. Well, I know that potassium is going to form a +1 charge. I know sulfur is going to form a -2 charge. So if I was to flip the switch, right, I'm going to go potassium, and there's 2 here. So on the sulfur, so I go potassium 2, and then I only have 1 charge for the potassium, so that's K2S. All right, what about the next one? Calcium chloride. I know calcium is going to be a 2 plus. I know chloride is going to be 1 minus, right? Flip the switch. I end up with calcium, and chloride only has one, so 1 calcium, and then chlorine, and then there's 2 of them right there, 2 up for the charge of calcium, Cl2. Aluminum, 3 plus. Oxygen, 2 minus. Okay? Again, you can do it the long way, which is fine, or you can flip the switch, and I'm going to take this number and put it there, and I'm going to take this number and put it there. So my answer for aluminum oxide is Al2O3. All right? If you guys have any questions, please ask in class.